According to a study conducted by the University of Michigan, up to 60% of near-Earth objects could be dark comets, mysterious asteroids containing or having contained ice that orbit the Sun in our solar system. These objects might provide a pathway for delivering water to Earth. The findings suggest that asteroids in the asteroid belt, a region of the solar system located roughly between Jupiter and Mars that contains most of the rocky asteroids in the system, have subsurface ice. This has been suspected since the 1980s, according to Aster Taylor, a graduate student in astronomy at UM and the lead author of the study. Taylor notes that the study also shows a potential pathway for ice from the near-Earth solar system to be delivered to Earth. How Earth acquired its water has been a long-standing question. We don't know if these dark comets delivered water to Earth. We can't say that. But we can say there are still debates about how exactly Earth's water came here, Taylor said. Our study shows that there is another way of delivering ice to Earth's environment from the rest of the solar system. The research also suggests that a large object could come from Jupiter family comets, which have orbits bringing them close to the planet Jupiter. The team's results were published in the journal Icarus. Dark comets are somewhat mysterious because they combine characteristics of both asteroids and comets. Asteroids are rocky objects typically orbiting closer to the Sun in a region called the frost line, where any ice they might carry would sublimate or turn directly from solid ice to gas due to the Sun's proximity. Comets, on the other hand, are icy objects that often show a fuzzy coma, a cloud surrounding a comet. Sublimating ice carries dust with it, forming this cloud. Additionally, comets typically have slight non-gravitational accelerations caused by the sublimation of ice rather than gravity. The study examined 7 dark comets and estimated that between 0.5% and 60% of near-Earth objects could be dark comets that lack a coma but exhibit non-gravitational accelerations. The researchers also suggest that these dark comets likely originate from the asteroid belt. The presence of non-gravitational accelerations in these dark comets indicates that asteroids in the belt contain ice. We think these objects come from the inner and/or outer main asteroid belt, meaning there's another mechanism allowing some ice to enter the inner solar system, Taylor said. There may be more ice in the inner main belt than we thought. There could be many more objects like this. This could be a significant part of the nearest population. We really don't know, but we have many more questions due to these findings. In previous work, a team including Taylor identified non-gravitational accelerations in a series of near-Earth objects, naming them dark comets. They determined that the non-gravitational accelerations of dark comets likely result from small amounts of sublimating ice. In the current study, Taylor and his colleagues aim to discover the origins of dark comets. Because the near-Earth environment is chaotic, near-Earth objects don't stay in their current orbits very long, Taylor said. They stay in the near-Earth environment for only about 10 million years. Since the solar system is much older than that, this means near-Earth objects must come from somewhere. We are constantly replenishing the near-Earth object population from a much larger reservoir. To determine the origins of this dark comet population, Taylor and his co-authors created dynamic models assigning non-gravitational accelerations to objects in different populations. They then modeled the paths these objects would take over a 100,000-year period, given the assigned non-gravitational accelerations. The researchers observed that many of these objects ended up where dark comets are currently found, concluding that the main asteroid belt is the most likely origin among all potential sources. Meanwhile, the study reveals that the rest of the dark comets likely come from the inner band of the asteroid belt. Since dark comets are likely to have ice, this implies the presence of ice in the inner part of the main belt. The researchers then applied a previously proposed theory to the dark comet population to determine why the objects are so small and spin rapidly. Taylor described comets as rocky structures held together by ice, similar to a dirty ice cube. When they encounter the frost line of the solar system, the ice begins to gas out. This causes the object to accelerate, but it can also cause the object to spin quite fast enough to break apart.